Hi there, and welcome to a new episode of Impact Talks. Today we have Michiel Selier with us. He's an aerospace engineer and an entrepreneur in aerospace, transport, logistics, and defense. Michiel, please introduce yourself to the people. Tell them where you're from and what you do.
Hi, very nice to be here. So thank you very much for inviting me for this. So Michiel Selier, indeed. I'm an aerospace engineer. I'm based in the Netherlands. I've been born and raised in the Netherlands as well. I've graduated from Delft University of Technology, and after that I started working at the Netherlands Aerospace Center, also in the Netherlands. And after that, in 2015, I decided to take myself out of my comfort zone and become an entrepreneur.
So I want to start at the beginning, like we always do at these podcasts. Why aerospace engineering? Why not any different type of engineering?
That's a very good question because I actually I have a very wide interest area. I think part of that decision was made because my uncle is an aerospace engineer, and beside it, I think I've always had a passion and an interest for flying. It's just something very magical if you see these heavy aircraft take off into the sky. It always, I would say, really puzzled me how that works, and I wanted to find out why and contribute. And yeah, I think early on I developed a passion in aircraft. So.
I think the main question that I've had maybe prepping for this podcast, and I think that a lot of people tend to ask nowadays in the world, is electrical flying. Partially why we've invited an aerospace engineer, but also somebody who's an entrepreneur in that space, is because I know for a fact that you've encountered some of these things. So I definitely want to cover your history and how you ended up there. But before we go really deep into your history, I wanted to know what type have you encountered electrical flying? How far along are we? Clearly you're qualified. That's why I asked about your history and how you started with it. Tell me about electrical flying. Well, what is your opinion on it?
So it's very clear that we have a big climate challenge. One of, I think, the main problems in the world, and a key problem is that it is a very sneaky problem. Climate change doesn't happen overnight; it happens gradually. But it has become very, very clear now that we need to do something with the climate. So, and in general, I think throughout my career, I've always worked on making aviation either cleaner, safer, or cheaper. Basically, so so far I would say you see in aviation that we have a lot of evolution, making aircraft a little bit more aerodynamic, making engines a little bit more efficient, but we really see that in the past few years that a step change is needed. And we really need to go towards zero emissions, and because there has been advances in battery technology and electric mobility, especially the automotive industry, of course, has made big steps in the past decade. It has also become feasible now to start with electric flying, and the whole idea about that is basically to make it more sustainable and create a zero emission, if possible, flying experience.
What has stopped the industry? Because I have a feeling that the airline industry has much more cash and budget than the car industry. I mean, maybe that's just me assuming. But why did they have to wait for the car industry before they could catch up?
The main, I would say, challenge for electrical aviation is the energy density of batteries. Obviously kerosene and actually also normal fuel is very energy efficient, which is the reason why we use it so much in our daily lives at the moment. But weight is always very critical for aerospace companies. So you need a good energy density density of the fuel in order to make it work for aviation. Because the more you take with you, if the fuel itself starts to weigh a lot, you need to take more fuel to carry the fuel. So it's like a sort of a cascading thing. And even at the moment, the battery density of the energy density of batteries is about 60 times less than kerosene still. So we definitely have some steps to take there. So that's why it's been difficult, I think, to introduce this into aviation. And another thing you mentioned that the aerospace companies have a lot of cash. Well, actually, aerospace is a business, especially the airlines. It's very competitive at the moment, and margins are very thin. So in that sense, aerospace is not in that sense an industry where there is an abundance of cash, unfortunately. And then a third reason I think why that happens slowly is the certification requirements. Obviously, if you need to put anything in an aircraft, it needs to be extremely safe and up to the normal safety levels of aviation. And that always takes time and money to develop that. So that's also a reason why innovations in aerospace tend to take more time than you would like them to take.
How come you got so fascinated with making airlines or just flying more sustainable? Like, how did you end up, I guess, in that career is my question. Was there something during your education that was happening? What triggered you to go into that?
Yeah, I think everybody, and including myself, likes to leave something valuable in the world and to add value and to do something meaningful. At least I like to do something meaningful in my work, and that is actually one of the key drivers, I think, is to work on meaningful subjects and preferably with nice people as well. That's I think has been a key driver all along. And yeah, when I studied aerospace engineering and started to work early on in NLR, you see that there is a need to make it more efficient. First of all, to make it more affordable, because fuel consumption and the cost of flying are already, I would say, attached to each other. So there's always been a drive to make aviation more efficient, and that's, I think, the way I rolled into it. Although I've encountered many subjects during my career on improving aviation, reducing the fuel consumption has always been one of them. Yeah. We really need to do something. All the other industries are moving, and aerospace also needs to contribute its share. So.
What kind of subjects have you encountered as you progressed through your career?
I've done quite a lot of things. I've done a lot of work on drones, which are now, I would say, more and more finding their ways into our lives, obviously, because also there has been a big revolution in microelectronics and making everything smaller. So now we have all these nice small drones flying around, but I already started working on those and looking at civil applications of drones around 2000. So 20 years ago, and at that time it was also again quite difficult to work with the regulations, the certification of drones. How do you make it safe? So that's a subject I worked on. I worked on aircraft noise a little bit, especially modeling the approach that aircraft make to the airport and try to find ways to make sure that the perceived noise on the ground is as little as possible and still have a safe approach to the airfield. So that's something I've worked on. And yeah.
How can you go a little? I'm just fascinated by something like that. Like, how do you do that?
So one of the things that people worked on in those days is the advanced continuous descent approaches, as they call it, and that basically means that the traditional approach is where you talk to the air traffic controllers and they just clear you for a certain flight level. So you come down from typically 10 kilometers in steps to a certain flight level, you get cleared, but every time you go down and you come to that flight level, you need to gear up the engine a little bit to go from descending flight, which is obviously very energy efficient because gravity is doing the work for you a little bit, but then you need to go to horizontal flight again, so you need to power up a little bit. And at this stepwise approach, every time you need to power up a little bit, and at some point you're flying at 2000 feet, which is 600 meters, And for example, here in the Netherlands, there are some approaches that go over cities like Leiden, for example, a typical city where aircraft tend to level off exactly above the city. They need to give some additional thrust to keep the aircraft flying, and that makes noise. And with a continuous descent approach, the trick is actually to basically from a certain level just glide all the way to the airport and try to give as little thrust as possible, and try to also change the thrust as little as possible, because it's also the thrust changes that you perceive. That's the moment you look up. Perhaps you relate to that. If you hear an aircraft and suddenly it starts to make more noise, that's the moment that you look up. So it's also not just the absolute level, but the changes. And this you try to avoid with sort of a gliding flight. And the challenge that you encounter then is that if you let aircraft loose in terms of the speed and the altitude where they're flying, as air traffic control, you're also losing grip, so to speak, on the spacing between the aircraft a little bit. So the trick is to make sure that you can do that safely and still get, especially on very busy airports, still get the airport capacity that you need. Because obviously you can space aircraft 10-20 minutes apart, but if you need to land every 2-3 minutes, like is the case on busy airports, then you can't afford to do that basically in the rush hour, so to speak. So to make that safe, these gliding flights, that was the challenge.
I've sorry for keep asking these questions because I'm always interested because I've flown a lot. How does an airport like Amsterdam manage to get these airplanes every 2 to 3 minutes? I feel like one of them will kind of screw up and have to redo the whole thing. So does really nobody screw up and just land every 2-3 minutes, or are there like a couple of people who like pilots that tend to screw up, have to redo the whole thing, and then like how does one handle that?
Yeah, that's a very good question. So you have the air traffic control who's actually guiding that. So they already see the aircraft coming and they know the flight plans really well ahead. And it's actually their job to sort of space them on the approach to such a way that for the pilots it's then just following the instructions basically. It is actually quite easy to keep apart. Obviously, sometimes something goes wrong, especially if weather conditions are bad. In the case of storms, for example, then it becomes much more difficult for aircraft to land, and sometimes then you see that somebody needs to do a go-around, as we call that. So they're almost on the tarmac, and then they find out that maybe because the landing is not stable enough. So they give full throttle and take off again and retry the approach. And that, of course, then it's up to air traffic control to sort of deal with that and make sure that he gets spaced into the approach again in a nice way. So, and that's really, I would say, the art of air traffic control.
But so when there's a 2-3 minute window, I'm assuming that they have to space themselves after like 2 or 3 airplanes before they can come back.
Yeah, correct. Yeah. If you do a go around, then you'll have to go into the queue, so to speak, a little bit further on, and there will be a few other aircraft landing before you. Unless, of course, there is an emergency situation, then they will clear the runway and they'll put the other aircraft on hold. If there is a really big reason why you need to land urgently.
We're gonna obviously cover still like all the projects you've worked in, especially like the first one I'm very interested in with the National Space Laboratory, I think it was.
Yeah.
But still on the airplane side. So from my understanding, the whole flight is done by autopilot, but the takeoff and landing, that's where the pilot comes in. Is that correct?
Almost correct, I would say. Takeoff is definitely something that usually pilots are still involved in. Then indeed, I would say the whole cruise flight is usually done on autopilot. And then the landing, that can be either done by the pilot or that can be done automatically actually. Depends a little bit on the equipment of the airport, but all the major airports, they have the right equipment on the ground to help the aircraft land automatically. And it also depends on the equipment on board of the aircraft, of course, and I would say the certification level of the autopilot. But all modern I would say airliners, larger aircraft are capable of an automatic landing.
How does automatic landing work?
Okay, so at the airport you have two radio signals being transmitted, what they call the glide slope and the localizer. So the localizer is giving basically the direction towards the airport. So it's just like a radio wave emitted in the same direction as the runway is located. And the glide slope is a signal which is under a 3-degree, I should do it like this, under a 3-degree angle, more or less to the start of the runway. So if you follow that signal down in the aircraft, you can basically, traditionally pilots used to do this. You can see these two radio signals, and you can sort of home in on them. And if you follow them, they'll take you right to the start of the runway. And that's basically been made automatic. So the aircraft detects that signal, sends it to the autopilot. Actually, there's usually a number of autopilots who are doing that at the same time in order to make it safe. And they basically calculate the inputs to the control surfaces, the rudder and the other control surfaces to make sure that the maneuver is executed safely and you end up safely on the runway. And then depending a bit on the autoland mode, usually also the taxi where the slowdown is included as well, up to the taxi.
So when it's landing, it's pretty much now on autopilot. Why isn't the takeoff yet automated if it's done with radio signals?
The takeoff is usually not done with radio signals, so that's usually the landing, and that is, as I said, performed automatic, but up to a certain wind level. If the wind gets too hard, the pilots need to do it themselves, and they also do it themselves usually just to keep current, basically, to keep practice. But I must say I'm not 100% certain on the automation of takeoff, or why exactly that doesn't happen. I think quite early on they switched to something automatic as well, but I think it's just especially the fact that they need to wait for the clearance to be allowed to take off, and they're monitoring the speeds, they're monitoring if the runway is clear. Nothing else gets onto the runway, etc. So these type of things are done pretty manual, as far as I know.
Cool. Okay, super technical questions. I want to go back to your history a little bit. So out of university, you get some of your first jobs. I think I think second job or something, you ended up in the National Aerospace Laboratory. What were you doing there?
Yes, that was actually my first job after university, and I stayed there for 18 years, so quite a long time. And I did many projects. So the project I mentioned on the drones, for example, is what I did there. I worked on wake vortexes, detection systems, especially when the A380 was introduced. So the bigger an aircraft is, the bigger you have these vortices behind the aircraft wing. Maybe you've seen that sometimes if they're landing in the fog a little bit, you see these two big vortices going. And actually, if you have a very big aircraft followed by a very small aircraft, there's always a risk that if you end up in this vortex, it will basically turn you upside down almost. So that's pretty tricky, so to speak. So I did some research on that, drones, and then especially focusing on autonomous flight and focusing on safety, how to make drones fly safely with other aircraft. I worked on flight control systems a little bit, autoland systems, so really a whole number of subjects. Noise, as I mentioned before.
So was it more of a research role that you were doing, or was your research, or like the things you worked on, was it eventually like implemented by some big companies?
Yeah, so NLR is a research institute, so we work together typically with the government and with industry, and in some cases with the Ministry of Defense if there are defense-related topics. We do the applied research, and that definitely gets transferred into, I would say, reality by industry later on. So That's usually the way it is. So I had a research role in the beginning of my career, and then at the end of my career in NLR, I moved to a more commercial, entrepreneurial role.
What type of commercial role does a research lab do then?
So I became a business development manager for the Aerospace Systems division, and NLR is not a 100% funded entity. So at the time, about 18 to 20% of the turnover of NLR was just government money to do certain basic research and to keep our facilities up to date. And the rest, I would say, is basically just going out there, like I would say, almost a normal company, and do acquisition and make sure that you get meaningful contracts from the various stakeholders in the segment. So in that sense, although research sounds like it's a very state subsidized thing, that is partly definitely true, but definitely not for all the money. So and there's also competition in that sense between research labs in Europe a little bit, which is not necessarily a bad thing, I think. So there is a lot of collaboration, but also sometimes some competition between ideas and entities for grant money. But also commercial contracts from companies. So we used to work for companies all over the world to do some research for them.
So my question is, because obviously, the event and all the startups that come through, but also just genuine interest from my side, because I love business development and sales. So how do you do sales for such an entity, I guess, a lab? Like, I'm assuming the clients are not small companies. Where do you start? You get put into that position. What does your first day or first week look like? Could you elaborate more on that?
Yeah, sure. Actually, NLR does work also with quite small companies. So we have a role. So NLR is a not-for-profit foundation. So although we have a commercial side to the company, it's all not for profit. So. And there's definitely a role for NLR in the Dutch ecosystem to help smaller companies to grow and to do research, to get access to the facilities that NLR has, because they're usually too expensive for definitely for smaller companies to have them on their own. So the fact that we had these facilities is very interesting for smaller companies, but even for larger companies. NLR actually together with DLR is exploiting some state-of-the-art wind tunnels, for example. So we used to get companies from all over the world, Embraer from Brazil, Comac from China, Airbus. They all used to come to the wind tunnel facilities. That was not necessarily my role in the company, but you see that we used to work for companies from quite small startups up to the very big ones that are out there in the aviation industry.
Can I just ask, out of interest, like a startup, what kind of budgets are they working with to use? Because I'm assuming you're renting out certain facilities for them then.
It's facilities and it's the knowledge, basically. So what type of budgets, that obviously depends a bit on the question. If you want to do a wind tunnel campaign, that is in the biggest wind tunnel, that is a very costly thing. So developing an aircraft costs billions, or definitely hundreds of millions. From start to finish. So and in that space, you always see that they're looking for support in engineering. That can be on aerodynamics, that can be on structures, that can be on systems, that can be on flight test support. That's something that we did also, is especially the newer companies in aviation, the new kids on the block. They were very happy with the experience that NLR had on flight testing and certification, for example. So that's something that we helped them out with. It can be a range of subjects, but it was usually either knowledge or facilities or both.
Okay, so then back to the sales question. What does your first day or first week look like? How do you even start looking? Are you just taking like Google and looking for space and aero? startups or companies in the neighborhood and just cold call them? Like, how do you do business development for something like that?
That's an excellent question. So the aerospace is sort of a niche market, and that has, I would say, good things and bad things with it. The bad thing is that there is only a limited number of customers out there compared to some of the other companies. But the good news is that they are usually not that difficult to find, so to speak. There is branch organizations. For example, in the Netherlands, we have the Netherlands Aerospace Group, where many of these companies are already a customer. There is a lot of trade shows, obviously, and it's also networking for a long time. And obviously, when you join a commercial role in an organization, just like in any other company, you have already other colleagues in the commercial team. There's usually somebody whose job you're taking, so it's not like you're starting 100% cold. You can start working on where somebody else left off, and then just find your own way, basically, in the ecosystem, and build up your network. And yeah, it's a small community globally, relatively small, I would say, compared to some other markets. But that also makes it difficult to get in, so to speak, because many people are knocking on the same doors. So.
So then 18 years there. Why leave? What was next?
So I did multiple roles in NLR. I always had actually a very great time doing those things. So I did the actual research. I became a project manager, program manager, and then the commercial role. And then at some point, I think after 18 years, you start wondering what life is outside of NLR in my case. And I always like to take myself out of my comfort zone every few years. That was also the reason to switch from the more, I would say, program manager, project manager to the commercial role, is also just to make a step and to keep growing as a person, and to get new skills, develop new skills, and see what you like. So in 2015, I also decided that it was time for something new. And then the question was, what was that going to be? I definitely thought about going to industrial companies, work with these larger industries. But I just did sort of soul searching with myself on what I found important in my career and in my work. And at the time at NLR, I would say there was quite a lot of freedom to work on the things that you like. Obviously, no absolute freedom; it's still a company, but they were always very good, I think, in giving people space to go after opportunities, and I really liked it. And I think doing that sort of soul searching made me to believe that I wanted to be an entrepreneur, become independent. And be able to, I would say, select the subjects I like to work on, companies I like to work with, and especially the causes I like to work on, like making aviation or transport in general more sustainable. And there was also another driver, my current business partner. He already had a company started up in transport and logistics, so it's a completely different direction. But he had a very interesting business model and a very interesting product, I thought. So it seemed nice I would say, as an entrepreneur, to go after it and see if you can build something for yourself instead of helping other companies to build their products.
Nice. So then you joined that company after.
I started my own company first, and he had his company. I joined his company, and then now sort of we sort of for branding purposes we're merging it all under one single flag, which is the Trans Innovate branch. But I'm still so working and in the transport and logistics and on the aerospace side, helping a bunch of companies get their products into the market and helping them find funding partners and customers.
So yeah, I want to talk about that phase in your life because it's super relevant to the podcast and the audience maybe. Can you talk about that journey of what type of projects have you worked on? What kind of things have you done? Because I know that obviously you've also worked, I think it was a startup for electrical flights or something.
Yeah.
But can you just shape kind of the I learned from stories. Can you share some stories?
Yeah, sure. Like I said, I started basically with my eggs in two baskets, the transport and logistics part. But at that time, although the idea was there was zero customers and zero turnover. So that was a bit risky because I do have a family and a mortgage, etc. But I could, when I left NLR, actually, some of the companies in the ecosystem already approached me and say, you have a great network you've got a lot of experience there, so could you perhaps help us? These are usually smaller companies on a part-time basis, helping us to grow and to develop business and to innovate. So that's how I started. And I think the first, in the aerospace business, the first company I helped out was a company that did backlights for cockpit displays and actually also other displays, but flight simulators, medical displays. So they do the technology that is literally behind the screen, trying to make that also more sustainable and more affordable and especially very high quality. They were focusing on the high quality market. Afterwards, I worked with a company on forest fires, when an innovation to make forest fire fighting aircrafts more efficient. So that was also an interesting project I work on, and after that since 2019 now I'm on a part-time basis. I'm working with Ampere, which is a startup in electrical aviation. And then in parallel to these, I would say, more structural support that I provide, I also do some smaller consultancy jobs in helping people to write proposals or sharpen their pencil in their ideas and their business models. So there's a whole list of smaller subjects that I work on in parallel as well. So, but those are usually short sprints of 2-3 months or something.
I have to say, those that the other little part that you mentioned, I think could be actually very useful, because obviously you have a ton of experience. A lot of startups need to write these proposals, all this stuff. What are some of the most common mistakes you tend to see? What is it that you actually do that makes it more valuable? Like, can you share some of these like proposals? Yeah.
Yeah. So I definitely see a lot of startups with very interesting ideas, and I think the most common mistake or pitfall, which I guess is very natural, is that people are very focused on their products and on the technical development of their products. So I'm usually typically always busy with, I would say, the high-tech industry. Mostly it's transport and aerospace, but I have done some other subjects as well. But there is always a technology component into it, and you see that the companies in the proposal writing, they want to tell everything about their technology and why it's so amazing. And the reality is that usually the evaluators that are actually need to evaluate these proposals for grants or investors, for example, sure, they want to make sure that the technology behind it is sound, but they don't have the knowledge level to fully understand it anyway. And what they would like to see is the much wider picture also of the business model and how do you come from now to implementation, what are the major risks, and especially the not obvious technical risks. The technical risks are usually very well known to these companies, but I always, as an example, I like to use the toilet, which has been patented somewhere in the 1780s, a long time ago, but it took like 100 years for it to become widely used, and the reason is that you need infrastructure for it. So you can have a toilet, but if you don't have the infrastructure, then you don't want one. And that's actually the same now with, for example, electrical aircraft or drones or some of these other new innovations. You need the infrastructure to support it, else it won't work as a business idea. Besides that, the product can be great. So I think it's that wider scope of things to see, okay, how is your product actually going to land in the ecosystem of the users and add value and make sure that all the stars are aligned well. For that idea to actually also materialize. I think that's something that I bring in for these companies. questioning them, and I don't always have the answers myself, but I tend to be able to ask the right questions to get them thinking about, okay, that's an important part too. And then the proposal gets much more balanced on not just the technology issues, but really on, okay, how can I take this into a mature market-ready product in such a way that infrastructure is there, social acceptance, all these other aspects that are important for a project to succeed are thought of.
Do you also have you worked on some startups that required funding or something, and you helped them with that?
Definitely, that's for most startups, that's one of the key things, of course, is to find the funding, especially if you're developing something with technology, and especially if you need large costs to build prototypes or test prototypes, then there is always a need for funding. So that's definitely one of the key things that I'm doing for these startups. So and that can be grant subsidy money. That's what I do quite a lot, and also a little bit trying to get to investors.
So how maybe very simple question, but like, how do you look up certain subsidies that you're aware of, or you contact certain investors you're aware of, or like, what do you do then?
So obviously the fact that if you're in that business, you find your way more easily. So there's definitely a number of subsidies that I'm very well familiar with. The number of instruments out there is also so large that it's impossible for, I would say, one person to know everything from all of them all of the time. So I tend to focus on several, especially ones that are used quite a lot by startups in the Netherlands and in Europe. European Commission grants and some national grants from subsidy, and then from investors. I also have sort of a list of investors that I try to approach with an idea, and not necessarily always immediately to get funding. I think it is always just even just talking to investors early on is very valuable to see if they're interested in the subject first, and also what for them would be the right moment to see this as an opportunity and to get on board. So I think that's also something very valuable. Going to an investor is not just banging on the door and say, here's my good idea, give me money. So it's really trying to explore also whether an investing opportunity should be a two-way street, actually. It's not just an investor giving money to a company, it's also a company that should present an opportunity to an investor, and I think it's trying to broker these two together the key thing.
So another question that I had then is regarding the other part-time that you're spending your projects on within your company. So can you tell me more about Ampere, or the startup that you're spending your time with? How did you get involved? What happened there? Did they approach your company, or
So for Ampere, I actually got approached by them because they're Susan Ying, who is the senior vice president of partnerships of Ampere, is somebody that has been in the industry also quite long, like me, and I think we met already once she was at Boeing. Somewhere in the 2000s. We met again when she was working for Comac, and I was at NLR working with Comac in China. Comac is the Chinese aircraft manufacturer. So we met again there, and then afterwards our ways separated again. But when Ampere is a US-based startup, founded in 2016. And they also realized they wanted to have foot on the ground in Europe, because they saw that the political climate in Europe towards sustainable aviation was, I would say, on a political level, much better than in the US, where at that time President Trump was in office, who had some, I would say, different opinions about climate change. And a different agenda. So and they also got a ton of requests to come to speak at conferences in Europe, and they felt that it was just good to have a European point of contact here to do, I would say, to be the representative and to be able to go to these conferences and to be able to expand the European footprint. And that, Susan approached me because she knew me, I would say, prior from the network. That's why I say network is quite important in the aviation industry. It's a small world, and I met up with Corey Combs, who is the CTO and one of the founders of Ampere after that, and I really liked their approach on the electric flying, and especially how they thought they were going to get this to the market, which I think was a very healthy and very pragmatic approach. So I got enthusiastic about that and started working with them in February 2019, so slightly more than 2 years now. And meantime, we have an English entity with 5 engineers now as well. So things are progressing in Europe.
I find it interesting that a lot of these US-based companies eventually end up opening offices in the Netherlands, especially because the Netherlands is so small. Do you have any idea why giants like a Tesla, or in this case, this startup, tends to choose the Netherlands?
Yeah, my take on that is that the Netherlands has a really good infrastructure. There it is again, in terms of knowledge. So we have definitely some very good universities here, 3 excellent technical universities, but also some others. I think also from a travel perspective, the Netherlands is quite easy to reach with Schiphol Airport and some train lines. So I think that helps. And in general, I think the climate to live here is great as well. And being in the Netherlands, you can quickly get access to European funding, for example. There's Dutch funding, so I think it's a mix of things. But the entire infrastructure and the ecosystem and I would say the travel. The easiness to travel in and outside of Europe from the Netherlands and actually to the whole world. I think that's the mix of things that makes the Netherlands quite appealing to US companies to come here.
Then I wanted to ask about the conversations that you just talked about with the CTO and everything. Can you explain what they explained to you that made it so interesting?
What I really liked in their approach on electric aviation is that in general, as I told you before, innovation in aerospace is usually time consuming, and it is quite costly because of the certification requirements. Everything needs to be designed safe, but you also need to prove that it's safe, and that just takes time. You need to interact with the aviation authorities to prove that it's safe, and they will scrutinize your. They won't trust you on your pretty face, basically. So you really need to show very detailed that you are meeting the requirements. And if you are doing something new in aerospace that is not covered by the current requirements, you're even, I would say, in bigger trouble because the regulators need to invent the requirements, or at least agree with the industry on those new requirements. So, and that's just a time-consuming process. And if you want to build a new aircraft from scratch, in general, even without too much innovation, that is already a project that is usually costing like hundreds of millions because of the prototype building, the flight testing, the certification, maybe in some cases some internal tests. So that is really serious investments that you need to put on the table. And what I liked about Ampere is that they said we are not going to try to build a fully new aircraft with a new energy carrier, which is new for the regulators, and new types of engines, which are the electrical power units, EPUs. So that's a lot of new in there, and that is probably like a very long path to the market in terms of time and especially also money. And they said, okay, let's start with taking existing aircraft and retrofit them to hybrid electric initially. By that you only focus on, I would say, what is really new, which is the electric energy storage and the electric propulsion. You still leave some of the older, and I would say, trusted technology in there as well. The still conventional combustion engines. Although you do want to equip them with something that can use biodiesel or sustainable aviation fuel so that you can still make it more sustainable than it was. But that step to the market, especially in terms of the development money that you need to adjust an existing aircraft, is easier than to develop something from scratch. So I thought that made perfect sense in terms of trying to get to the market quickly, starting with smaller aircraft, certify them, sell them, get them out there and make sure that there is data, because what you really need to prove if you want to scale up, at some point you come with a certain component and the regulator will ask you, okay, how reliable is this component actually? And you can say all you want, but what I would really like to see is data. And if you can say, well, we've flown now on the various aircraft out there, we have flown so many hours with this technology, we've had this amount of failures or incidents or something like that. So you can just prove basically how safe it really is, and that will make the next step easier if you want to scale up to something bigger where the requirements get more stringent usually.
So just for me to understand, they pretty much make an airplane like a Toyota Prius, a hybrid system that has both electric as well as gas propulsion.
Initially, yes, yeah, and that has two reasons. So as I mentioned before, the energy density of batteries is not such that if you would make something fully electric, the range that you will get with a decent payload will be fairly limited. And in order to get something into the market that is more widely applicable, although electric flight I think is the best for short hops at the moment, there's definitely, but there's also big opportunities there. There's a lot of smaller airports that are hardly utilized at the moment. So what Ampere is really aiming for is doing much more point-to-point short hops between these regional airfields and avoiding the busy big airports where you need to wait 3 hours in line to get through the passports and the luggage and the check-in, etc. So it's also about not just electrifying aviation, but really changing the way the aviation system works. And by changing something into a hybrid, I think that's just the fast step to the market, a little bit like the Prius story indeed. So, and then obviously the end goal is to electrify it fully, make no mistake about that, but it's basically not try to jump on the moon in one shot, but take sensible steps. And each of these steps should make market sense, and there should be a business case for it. And that will also, at least that's the idea that we have, it will also keep investors engaged better, because they see that the return on investment is after a shorter period of time than if you would develop something fully new.
What I don't understand is the hybrid system, because you just explained to me that electric is 60 times less efficient at getting, propulsion out. So if you put in like an electric engine in there and make it hybrid, aren't you just making the aircraft heavier? Or like, how does it work?
Yeah, so the factor 60 is basically the energy density. So if you take 1 kilo of battery pack and 1 kilo of kerosene, there will be 60 times more energy in the kerosene. So correct. There's definitely a weight drawback of using these batteries, and that's why I would say the first step is most likely in doing a hybrid. Because if you want to take everything with batteries, you need very big battery packs, and especially if you go to the retrofitting market, what Ampere is doing, these aircraft weren't designed initially, of course, thinking about, okay, let's put a huge battery pack in our aircraft somewhere. So in that sense, you'll have to switch to a hybrid initially before you go to fully electric. And for fully electric, then it's probably also makes more sense to develop a fully new aircraft that is really tailored to full electric flight.
But even with the hybrid, if the energy density is so much less efficient, why would you even put it in there? Like, is the battery designed in such a way that it actually makes sense, like in a Prius, where it just literally makes sense to have a hybrid? Is there some innovation that came in, or are they just sacrificing, weights and just for the sake of sustainability, but not actually innovating.
Yeah, it's mostly range that you're sacrificing. The aircraft, the hybrid aircraft will fly less far than a normal fuel aircraft. But if the distance that you can cover is still interesting for passenger flows, if you look at some of these aircraft, they can actually fly much further than they actually do in daily operations. They're operating on very short routes, and so we're actually with Ampere, we hope to be allowed to fly next week in Scotland between Wick Airport and Kirkland Airport. So Wick is on the mainland and Kirkland is on the Orkney Islands. So that's, for example, a route which isn't very far. The alternatives in transport are less. I mean, you can't get there with a car or with a train because it's an island. So flying is definitely a good way to go there, and on these distances, electric works really well. What you do with the hybrid initially is that you use it as sort of a takeoff assist. Most of the energy that you're using during the flight is used in the takeoff to get to the cruise altitude. So if you use the battery there, you will save regular fuel. And because electrical energy is cheaper than fuel, ultimately that should save you fuel costs. And ultimately the idea is also that, especially if you switch to fully electric, that's the same with the cars, that electric engines have less maintenance than combustion engines because they have much less moving parts in there. So in the end, the idea is to reduce the operating costs of the aircraft on the shorter hops, and decrease the maintenance cost. So that's where it makes sense. But you do sacrifice. You're right. You do sacrifice on range.
But so how much range are we talking about? Because right now you guys are testing just the short flights, like a hybrid flight. How far can you get with that? And how far can you get with the same technology that is currently available on a fully electric flight?
Yeah, so if we look at at the moment we have a Cessna 337 retrofitted flying as a test bed, which I said will fly next week in the UK, and it has flown already in California and in Hawaii with Mokulele Airlines before in test, and not with passengers. The range we can get out of that aircraft, the longest flight we did is actually 500 kilometers, so that's still a decent range.
Yeah.
And then we're really squeezing, I would say, the range out that we can get. That is definitely less than the range of the original aircraft, like by a factor of 2, I think. So, but yeah, 500 kilometers is a decent range that you can use. If you would go for fully electric, you would probably end up with something closer to 15 to 100 kilometers maximum range with this particular aircraft. So that starts to be, I would say, less appealing. Next, we're aiming at 19-seat aircraft, the Twin Otter, which is an aircraft that is widely used, for example, in Scotland or England, but also in the Caribbean. So definitely a lot of places in the world where they're using this aircraft. And with that aircraft, we also still think we can get a decent range up to between 250 to 500 kilometers out of the aircraft, which for quite a lot of routes is sufficient.
Okay, 15 to 100 kilometers is something I didn't expect, especially because you have Teslas that are going to come close to like 1,000 kilometers soon. Is the development of what Tesla is doing with batteries, is that helping with electric flying?
I think in general, yes, of course, because also although for cars the weight is less critical, so to speak, you don't need to get the car off the ground. That's where it goes wrong. So with aircraft you need to take off, and every kilo of weight just accumulates into additional structure that you need to carry the weight, etc. So it just, that's like always a snowball effect, as we say. So that's less there for cars. But obviously the more electric vehicles we get out there, cars, potentially also looking at trucks, there looking at also in the maritime industry more and more they're trying to look at more electric propulsion as well. So and then there is of course
Actually, one of the winners of our event, Scone Energy, they help electrify ships, and they've been doing it for the last 2 or 3 years. I think they were our first winner, and they got. I remember they got an investment from Damen Shipyards, so they're really trying to do that. So yeah, sorry, continue.
Yeah, no, sure. No, so you see, electrification is everywhere, and that I think is the good news, because that will definitely help trigger I would say the battery companies to try to get more and more energy dense batteries, which is actually also for your mobile phone already pretty useful if you can get a decent amount of time out of your phone and it doesn't weigh a ton and it's not very big. So so I think the demand for more electrified mobility will drive the battery technology to improve, and that's also something that we hope for, obviously, with Ampere, is that these batteries will become better and better, and as such the range will increase, and electric flight will have also a better range in the future.
Why do you think the battery companies have not improved in such a long time? Do you think it was just demand? There was no demand to improve? There was like...
I think they have been improving, and actually they've improved now to a level that it starts to become interesting for aviation, which wasn't the case, I would say, 10, 20 years ago. So in that sense, I think a lot of steps have already been made, and I'm not a battery specialist myself, but I know that there is also some innovative companies, also in the Netherlands, for example, we're looking at new battery technology that can reach higher energy densities. There's a company called Leiden Jar in Leiden, who have something very interesting ongoing, which we are following that, of course. But before you get the battery technology proven is one thing, but to get it certified into an aircraft is another thing. Because one of the key risks with batteries, of course, is fire, as you probably know. So you don't want to get a battery pack to catch fire and just burn up, because that goes. I've seen movies about from that. That's very violent. So that's something that you want to avoid. So and which can be avoided if you just do a good design and keep the cells, the individual battery cells, separated in a good way. But that's so to get from, I would say, a battery that is working as a concept to a certified battery for aerospace. That again is taking some few steps, because you need to make sure it's absolutely safe.
How long do you think realistically we're going to even be able to switch to hybrids in electric flying, sir?
Yeah, so if you look at we're actually there. So the Cessna 337 that Ampere currently has is flying. So that's.
Oh, I mean commercially flying on the Boeing or something.
And commercially flying, I think we're aiming to get aircraft on the market by like say 2025, the middle of this century. Actually, there is already a fully electric aircraft from Pipistrel. The Electro, they have an electric aircraft which is certified, but that's only a two-seater. So that's not really for, I would say, commercial transport. Very interesting, but it is interesting for training flights. And also last year there's been a company in the Netherlands, E-Flight Academy, which has started up the first company that is offering getting your pilot's license for a large part in an electric aircraft. So although that's not commercial transport yet, you see that really the first applications, even in aviation, are already here. And I expect, or at least if you look at the market outlooks from Ampere and from a number of other companies, they're all trying to get the first aircraft for commercial use out by, say, around 2025.
But so training pilots, I am assuming their 100-kilometer range is enough, or what?
Yeah, so this is really the basic pilot's license that you will get initially, also for hobby flights, basically. There's a lot of people that have a pilot's license on just a single engine airplane. So this is a type of training that you could start with. Really your first flying lessons you can do in this aircraft. And then you can do already quite a lot, indeed, with a shorter range. In the end, for your license, you do need to make some longer distance flights, and then I think at the moment they are still using conventional aircraft, which anyway is probably not a bad thing, because if you're training in an electric aircraft, won't be saying that you will be flying in an electric aircraft afterwards also. So it's probably also a good idea to get some training hours on a normal conventional fuel aircraft as well.
Because if you're training in an electric airplane, is it really the same as a gasoline airplane? I mean, for cars, I can assume it's quite similar because you have the same pedals and everything. But like I don't know, is it the same for an airplane like it is for cars?
Yeah, I think that the controls are very, very similar. So in that sense, like with the cars, there isn't a really big difference. Also, the way that you control the aircraft is still the same. There are still the same elevators and rudders, so you still have the same stick to steer the aircraft. It's just that the thrust works well slightly differently, because the electric engines are responding faster actually typically than a combustion engine. But that's in the details, I would say, and that's the same actually with an electric car. You also it accelerates faster, and you have these modes where if you release the gas pedal, you're immediately starting braking and recharging the battery. So there are some differences with the cars also, but they're fairly small to I would say normal flying. So it's not completely different.
So maybe I skipped over this. Maybe you said the answer, but so for commercial flights, you said 2025. Is it? Are you talking about like Boeings then, or like?
No, that will really be the smaller aircraft. So you'll see probably 9-seaters, 19-seaters maybe. So that's more or less the range that you need to think of, because electrification of I would say the Airbuses and the Boeings and the Amsterdam-London flight, that's really a long time away, because there I would say the energy density is working against you, and especially if you look at transatlantic, for example, flights. A key, I would say, a benefit, so to speak. Actually, it's not a benefit because it's polluting, but if you fly over the Atlantic, you should think that for Boeing 747, about 30% of the takeoff weight is fuel.
Jesus, but can't you put like electric there just for the takeoff or something?
Well, for these aircraft, they're looking at electric taxiing, for example, and taxi bots on the airport to make the taxiing more efficient. But for the actual flying, especially on these longer ranges, you can normally take benefit by the fact that you are burning all this fuel and your aircraft gets lighter all the way. And because it gets lighter, you need less fuel to keep it in the air at the end of the flight. But like I said, that's the benefit for weight, but that's a drawback for the environment, because that fuel that you're burning ends up in the atmosphere, obviously. But batteries don't get lighter. So for these really long ranges, even if you deplete the battery, it doesn't get lighter. So you miss this sort of weight advantage. So for these larger type of aircrafts, I think you will see that the shorter term solution will be much more in what I call sustainable aviation fuel, where they're trying to get CO2 out of the atmosphere and turn that into synthetic fuel and then put it back into the aircraft, so that you're sort of getting it's not a fully closed loop, but an almost closed loop, and you can save up to 80% of CO2 emissions or something typically.
So pretty much it sounds to me like if we want to create a climate neutral aircraft, you either have to switch the fuel and create a closed loop environment like you just said, or just have biofuel somehow. But electric is just not going to be the solution for now, unless somebody invents a battery that is more efficient or more energy dense than kerosene.
Yeah, I think it will be a solution, but on the smaller ranges. So if you look at regional transport, it's going to be a very viable solution there. There's also hydrogen, by the way. A number of companies.
Yeah, I wanted to cover that actually in my next question.
So I'll keep that to the next question. But I think what we really need to think about is not so much when you're thinking about electrifying aviation, people tend to say, okay, I take the same plane that I have, I just switch the normal fuel for the batteries and I've electrified aviation. that I would say the aircraft is a means to get people from A to B. It is not this, the end goal in itself. So in the end, mobility is about moving people from A to B, and I think we need to start rethinking the entire mobility model that we have in the world. A lot of times I hear that rail, for example, should play a big role in regional travel in Europe, but do you know how much years it takes to put a railway in place between two cities somewhere? That usually tends to take decades as well, because it takes a lot of time, it takes a lot of money. Typically you need to make sure that the whole trajectory, you get ownership of the land to actually build the railway. So building a railway is, if the railway is already there, like for example the Amsterdam-Paris lane, that's a great solution, and take the train. That works well. However, if you look at cross-border flights, for example, from the north of the Netherlands to Denmark, that's not too far. But rail connections are almost inexistent there. So if you want to do that by rail, that is a very long, tedious journey. And you could do that with electric aircraft very easily. So electric aircraft on the regional level, especially looking at the fact that we have all these smaller airports in Europe and in the US actually that are hardly used at the moment. We could use those much more for the shorter distances, and it might even start to compete with the car. If you want to drive from Maastricht to Groningen in the Netherlands, that's a few good hours of driving. If you're doing that alone by yourself, versus if you could get onto a smaller aircraft and fly that distance electrically, then that could still be a good case. If we get, of course, the gasoline cars off the road, then that should be the objective then. But so I think we really
Is
should
there
look at.
enough demand for like small trajectories like that? Like, yeah, it seems to me like it wouldn't be a viable I mean, I wish it was possible, but would it be a viable business model to have an aircraft running from like the southernmost city to the northernmost city? Because it's not like you can take your car along, because when you arrive to, Groningen, which is in the north of the Netherlands, you still have to drive around.
Yeah, correct. But that's a good remark. So in the end, I think you need to look at door-to-door transport. People, you don't want to go from one airport to another airport. You don't want to go from one train station to another train station. You have, your home or your work, and you're going to another destination. So it's door-to-door travel. And I think in this mix, we need to see how to make that work, basically. And then I think there's a lot of potential for the regional electric aircraft, but also you see now the developments in the urban air mobility. So that's in the smaller segment for the shorter ranges, because roads also tend to clutter up a little bit, especially in rush hour. So there is a number of reasons why I think the demand could be growing, as long as the possibility is there. That's always a chicken and egg situation. If you have no possibility for something, then there's also no demand. Or it's a bit black and white maybe, but there is always a sort of a chicken and egg situation ongoing there.
I wanna go into, I think, the final topic we'll be discussing, but I think in the last, I would say even months almost, or maybe few years, I feel like a new player has been coming along, which is rocket ships, where before rocket ships were completely not realistic and comparable even to airplanes. Obviously, SpaceX came with the booster rockets that are reusable, everything. It's becoming more like airplanes, which is very kind of visible now that SpaceX is transporting astronauts to the ISS. But also, we've had some space engineers on the podcast. And now, a couple of weeks ago, with Blue Origin and Richard Branson also going up. I remember one of the tweets that I read from Blue Origin, which I thought was ridiculous that they posted that in the first place. But one of the things that they mentioned is that they have more sustainable fuel. I think they use hydrogen or something like that. And it seems to me like obviously hydrogen, or I don't know what they were using, but I'm assuming it was hydrogen, that if I remember correctly. So it seems like a more sustainable fuel because water comes out and everything. But I guess I have two questions there. If Blue Origin was able to use more sustainable fuel like hydrogen, how come airplanes can't do it? And is it really sustainable what they were using, or is it just they're talking? Because we had a space engineer on, and he said the issue is not the specific fuel that you're using. It could be even hydrogen or oxygen. But when you get into the upper atmosphere, and you're messing with the chemistry of the earth, you're putting in more hydrogen or more stuff into the atmosphere, it messes up the balance, and that's what's wrong for the earth, and not specifically what you're messing up. So I guess to phrase my question then, what do you think of hydrogen as an option? Is a rocket like Blue Origin sustainable, on the one side of the question? And then second, you being an aerospace engineer, how do you see this new like rocket thing coming up? Is that going to be maybe replacing aviation for long haul flights or something? I guess I just want your opinion
Yeah,
on those
yeah,
things.
sure. So I am not too familiar with the exact type of fuel that the Blue Origin used. I also heard indeed it was, I think, hydrogen based, but I'm not 100% sure there. But there is definitely also a lot of activity in the aerospace community to look at hydrogen, because hydrogen has a better energy density per kilo for sure than batteries, per volume also better, but because hydrogen is a very thin gas, so to speak.
How much compared to kerosene? If batteries was like 60, how much is hydrogen?
I don't know the number out of the top of my head. I know that kerosene for per kilogram is still, I think, maybe per kilogram hydrogen is even better. Per volume, kerosene is definitely better. So you would have to take a huge amount of hydrogen with you, especially in terms of volume. So you need to pressurize it, or you need to make it liquid in order for hydrogen to start making sense. But there are definitely a lot of activities ongoing there, because for the slightly larger aircraft, it has definitely some potential, I think. If you just look at a per flight basis. I think the other thing with hydrogen, but actually that's the same obviously with electric flight, is also where is that energy actually coming from? It doesn't make sense to start flying electrically if you need to burn coal to generate the electricity. That's just moving the problem around. So you need sustainable electricity. With hydrogen you have a bit of the same issue, because hydrogen doesn't really exist in nature in large quantities, so you can't mine it. You have to produce it, and usually people tend to use electricity to turn water into hydrogen and oxygen. But then basically you use electrical energy to generate hydrogen. There are always some losses in this process, so you're already losing some of the energy. Then you need to compress the hydrogen, store the hydrogen, transport the hydrogen. And in the end it ends up in the aircraft, it's burned, and quite often it's turned again, or you burn it like the rocket, and then you're inserting it into the atmosphere. And I am not 100% sure. I know that actually water vapor is also a greenhouse gas, but I think it might be less problematic than CO2, because water vapor tends to fall down as rain on the earth. So, but let me first say I'm not really a hydrogen expert there. But if you're burning it, it gets into the atmosphere. If you're turning it again into electricity, you've basically started with electricity, turned it into hydrogen, transported, taken all these steps, and then you're back to electricity, which obviously is I would say, really from an energy perspective is less efficient. But on the other hand, if it helps to decarbonize aviation on the longer flights and the longer ranges, then it can still make sense. So I think what we will see is, I don't like discussions where people are 100% black and white, pro electric or pro hydrogen, and saying, well, the other doesn't make sense. I think As you see often in innovation, that there is definitely initially there's probably a good place for both electric aviation and hydrogen aviation and sustainable aviation fuel. Also, sustainable aviation fuel has scalability issues with it. If you want to produce this, getting CO2 out of the atmosphere, if you see how much fuel we're burning on a daily basis in aviation, we need really to ramp up production in order to be able to do greening. So for all these three solutions, I would say the energy supply is definitely still a challenge, and probably for electric that is the easiest to solve with solar and wind energy. But there's never free lunch. I think innovation is always needs courage and needs time and persistence to make it work. But we do need to move. So
Maybe a very basic question, because I'm not an engineer. Is it like easy to maybe fit an airplane with some type of filter that kind of catches the CO2 out of the atmosphere, or is that just completely unrealistic?
It's an interesting thought. Obviously, just looking at how aircraft propulsion traditionally works is you are pushing yourself forward against the air. So you're taking a lot of air in the engine. You heat up the air, and that's where the fuel comes in. The air gets a higher pressure, and then you spit it out from the back, basically, and then it's mixed with the CO2. And the fact that you can spit it out the back at a higher speed or a higher momentum, actually, than what it came in with, makes you move forward. So you're pushing yourself against the air, so to speak. But you need the fuel to make that happen. You need to add the energy of the fuel, and you need to add the fuel to the air that you are emitting into the atmosphere. So, and if you would try to filter that out, I think that would lead to problems, because if you reduce the speed of the air coming out of the engine, you're just losing the trust. So I think that I'm not saying that I try to avoid saying that things are impossible, because 1 week from now an engineer may prove you wrong, but it's definitely not a solution that I know that they're looking into as I would say commercially viable solution for the moment. So
then the question regarding the rocket ships, especially I know that SpaceX wants to create these rocket ships that pretty much go from point A to point B like an airplane. I have no idea what Blue Origins is doing. It's getting a lot of hate nowadays because it's tourism. I wanted to be one of the pro people, but I don't understand if what they are doing is exactly just tourism in space, going 10 minutes up and down, or if they're also chasing the same idea, which I think they are, of going from maybe London to Shanghai in like 30 minutes or something like that. If that's the case, then I'm definitely pro Blue Origins and SpaceX. But so my question to you is, how you've been an aerospace engineer for so long, seeing what you've seen so far from these rocket companies, how realistic are their ideas? How viable are they to replace the long airplanes? Is this a case of like the car replacing the horse? I know. What's your opinion?
Yeah, so I think before we see this type of space flight being able to be safe for larger amounts of passengers, so you need, because obviously you need bigger spaceships if you want to carry a lot of passengers, and before that is developed and certified and scaled up to a level that we can replace long-haul aviation, I think we're definitely talking about decades. If it will ever happen, because that ultimately also depends on the economics. The idea with, I would say, low orbit spaceflight is, of course, that you spend quite some energy to take off and to get to a certain altitude, but obviously if you get out of the atmosphere or into the very thin layers of the atmosphere, the whole drag is much less. That's of course where the benefit is, where you can fly very fast without any aerodynamic drag. But then there is again the re-entry into the atmosphere, where there are also, I would say, some challenges in heating up and safely landing. And before we are able to do that in vehicles that I would say can also get a quick turnaround time, because at the moment, if you look at bigger airlines, they're coming in with the plane, they put all the people out in the airport, the suitcases, the cargo, etc., and they want to fly again in like 1 hour for the bigger planes. Technically, the turnaround time is like 1 hour. So they want to keep flying because in the end, aircraft are very expensive, and if you are buying one of them as an operator, you need to make sure that you in the end you have a good business case, and by keeping if you want to keep the ticket price low, you just need to fly a lot. And that's what they're trying to do now. And I think with space flight, if that will happen, it will probably happen more for I would say the business people and the rich and famous, with a higher ticket price initially. Just I think similar to supersonic flight at some point with the Concorde was. So I will not exclude that will happen, but I doubt that we will see that happen in this half of this century, maybe in the second half of this century. But famous last words, because many people have said things like this and were proven wrong 30 years later. So.
Well, hopefully you were proven wrong then. But I understand, because obviously you have to make it commercially viable. So pretty much you're comparing it now to a Concorde, which actually leads me to, I know it was the final topic, but I really want to know this then, because you brought it up. I have heard rumors that supersonic flight is coming back. Is this correct? Obviously you're more on the pulse than I am.
Yeah, there are a number of companies looking at supersonic aircraft again. So they're working on it. I don't know too much about the details. I know that for Concorde it was always tough. First of all, because of in the end, the fuel efficiency of that aircraft was an issue, and that's something that they're trying to solve now, also using sustainable fuels. So that would be great. Another thing that also people tend not to like about the Concorde is the sonic boom. If you fly supersonic, you get the sonic boom, and that's actually, I think, one of the reasons that they didn't like the Concorde fly overland, so to speak. So that's why they used it mostly on the transatlantic routes. So that's another challenge, I would say, that they will have to deal with. But
a quick question about the sonic boom. So when the aircraft passes the sonic barrier at 1G, does the sonic boom just happen in that spot, or is this like a continuous thing that is happening?
It's a continuous thing. So it's Mach 1, the speed of sound. Actually, what you will see is as soon as you are approaching Mach 1, there are already spots on the aircraft where the air itself will go faster than Mach 1. Because one of the reasons aircraft are flying is that on the top of the wing, the air is moving more quickly than on the bottom of the wing, and that's in some cases how you create lift. Although with Concorde, I think it uses vortex lift. So when you start to approach Mach 1, you start to get already locally sometimes some of these small, I would say, shock waves on the aircraft. But the moment that you break Mach 1, then definitely you get a big shock wave typically from the nose tip of the aircraft. But that doesn't go away. If you go past Mach 1, that shock wave is still there. It's just that if you are flying almost Mach 1, it's more or less like a curve, and the faster you start flying, the more of a sort of a steep triangle it starts to become, this shock wave. But it will stay there, because you're basically because you're flying faster than the speed of sound. It basically means that the air molecules, there's no air molecules, but the molecules in the air they don't have time enough anymore to get out of the way, so to speak. So they're really violently bumping into each other. That's where you get this shock wave. So it's just physics.
So the sonic boom is the bumping into each other actually. So it's
Yeah, the
not like
molecules bump into each other at some point, and but there's usually that's the way sound propagates. Is just the fact that molecules bump into other molecules in the air and finally reach your ear. But the problem is that once you read the speed of sound, is that you're actually going faster than those the molecules in the air can move. So you're violently pushing them forward, so to speak. So if I can sort of say that in non-engineering terms, but that's what happens, and that's where you get the shock wave. Is that you're going so fast that the air sort of cannot get out of the way on time anymore, in a normal way. So you get the shock waves. Yeah.
so it's almost like you're crashing into a wall, a continuous wall of air, and that boom is then those crashes that you're doing.
Something like that. Yeah, yeah,
Okay.
yeah.
But so it's not like I imagined it, obviously not being an engineer, where you see all those pictures of the sonic boom. So it's not like this one sound and then it's like normal silence. It's just the whole time you have this super loud boom thing.
Yeah, you keep having this, and that's also why you see that the shape of the Concorde, which went like twice the speed of sound, is very long. Is because they want to make sure that the sonic boom, the shock wave that comes off the nose of the aircraft, doesn't hit the wings further on, because there it starts to look really like this, and you need to make sure that the shape of the aircraft with the wings is more or less inside the shape of the shock wave, because else you have this shock wave which also causes vibrations on your aircraft, and that's something from an engineering point that you would like to avoid. So the faster you want to fly, I would say, the more I would say long you need to make your aircraft, or you need to find a way to deal with this shock wave over your wings. But
So the sonic boom, is that something that the passengers hear, or how does it work?
I've never flown in Concorde. As an aerospace engineer, I would have definitely liked that. But I did see a documentary once where one of the passengers was very disappointed on one of the first flights, and he told the chief engineer that I would have expected to hear something from this sonic boom, but I don't hear it. And then the chief engineer said that was the hardest part of the design. So, so from that I conclude that you don't hear it as a passenger, and I can also imagine if that would be a continuous thing that you would hear all the flight, that wouldn't be very comfortable. People like to fly.
Yeah, I wasn't aware if it's a one-time thing that you hear as you pass the border, or a continuum, but now I understand the physics of it. Then maybe a question from somebody who likes airplanes. The Lockheeds, which I think is still the fastest airplane ever designed, hit sometimes like 4 Mach 4 or something like that. And it was originally designed as a spy plane, so it flew really high. That's how it achieved all these speeds. But because it was a spy plane, I'm assuming it didn't have a loud sonic boom on the ground. Otherwise, it would have been caught.
Yeah, so I think you're referring to the SR-71
Yeah,
Blackbird, so
exactly.
that black
The Blackbird,
plane. Yeah, that flew about 3 times the speed of sound. And they were flying very high, so I think the impact of the sonic boom would be less on the ground. And the other, I would say, good news with the sonic boom is that you will hear the sonic boom always later than because the aircraft is flying faster than the sound. So in that sense, the aircraft will have passed you by the time that you will have heard it. But to be honest, I'm not quite sure what the exposure to the on the ground for the SR-71 was. But they definitely try to be already a little bit less visible on the radar, which became a big thing after. But already they tried in those times to be less visible on the radar. But yeah, detecting an aircraft by sound for something that is flying faster than sound is you're by the time you've detected it, you're too late. So if you want to take it down with your missile, then people tend to rely on radar. And at some point, these radars and these missiles became also better and better, and that's why they abandoned these super fast spy planes, because it started to become more and more tough to outrun the missiles, basically, and at the same time satellites became much more easily available, so they just switched to satellites.
Because I was thinking well, obviously you don't know what it sounded like on the ground, but I thought that it was probably silent on the ground because it was so high. Of course, I don't know. And so then the solution would have been for supersonic flights that it would just go really high.
Yeah, that definitely helps. Obviously, because the sound sort of dissipates a bit. Sometimes you see these nice movies on the internet where you have a supersonic flyby from a fighter jet at really low altitude, and then you hear this intense bang. And I think if you fly higher, it will dissipate a little bit in the atmosphere. So that will probably help to some extent, but. To be honest, I'm not 100% sure on the dynamics of how high you would need to fly to make it completely silent, but it definitely does help.
So at one point it would have to become a spaceship. Clear. Okay, we've been talking, I think we're nearing the end actually, but before I let go of you, I wanted to kind of roll out the red carpet for you. Maybe tell the people kind of where they can find you, what you're working on, and also do you have any last words for the audience?
Yeah, where you can find me. People can, if people are interested to reach out to me, I'm on LinkedIn, Michiel Selier, so you can definitely find me there for sure. You can always approach me for any questions related to technical innovation and sustainable aviation in general. I always like to spar with people and to share thoughts, so people are always welcome to reach out. I think one last thing I would like to say to the audience is that making aviation sustainable is a marathon, and sometimes people get hyped up too much. You have the famous hype curve, I guess. You see that now also with urban air mobility. There's a lot of companies working on it. It's getting a lot of attention, and in reality, innovation is usually it's a marathon that we're running. And I tend to compare the innovations, the revolution that we're doing now in the aviation industry, switching to zero emission or sustainable modes. If you go back 100 years to the start of aviation, the first flight of the Wright brothers was something like 37 meters at Kitty Hawk Beach, so a very short flight with only one person. If I translate that now, and for example, when people say, "Oh, we have the pipistrel now, and it is flying with 2 people," then people say, "Yeah, it's only 2 people, you know. It doesn't. What's the big deal?" If we would have said that 100 years ago with the Wright brothers, just say, "Okay, so 1 person, 37 meter. What's the big deal?" You know, you can't move forward like that. You need to think about the future, and you need to keep moving forward. The first actual passenger flight in aviation, as far as I could find it in literature, has been done in 1914 in the US, 37 kilometers, 1 passenger. So still not big business, so to speak. But then it started to speed up. London, Paris, first flight commercially in 1919. But it took 20 years more in order for us to fly transatlantic. And I think even a few of these early pioneers in aviation said, okay, flying is nice, but we will never be able to go transatlantic because the engines are just not good enough. To reach that. So and that you see that at some point you get caught up by technology. As soon as people see the benefit and as soon as the drive is there, I think we as a species, mankind, can be very creative in pushing things forward. And I really hope that people will have the patience and the persistence to pursue sustainable aviation and realize that this is a marathon. So we need to take it one step at a time, but we will get there. I'm pretty sure that we can make aviation sustainable.
I think on those inspiring words, we can definitely close this. It was an absolute joy having you on. I learned so much about aviation and the engineering part, so many things that I wasn't aware of, obviously not being an engineer. I think maybe also some interesting things for maybe startups who are trying to enter this, and some interesting topics of innovation. Super exciting to have you on, and yeah, hopefully I'll see you in the future on a different episode as well. Thank you so much.
Definitely. It was a pleasure being here. Thank you.
If you liked this episode, you can check out our most recent one here. And if you haven't already, make sure you click here to subscribe and see the next one. But if you're interested in more tips and tricks, then make sure to join our Facebook group where you can find thousands of like-minded people and you get direct access and support to